Welcome to our YouTube channel Technical Aviator. Today we will discuss about the bypass ratio and engine pressure ratio of gas turbine ratio. The bypass ratio and engine pressure ratio are two important parameters that define the characteristics and performance of a gas turbine engine. 1. Bypass ratio. The bypass ratio is a ratio that represents the amount of air that bypasses the engine core compared to the air that passes through the core and is combusted. 1. It is typically expressed as a numerical value, such as 5:1 or 10:1. In a turbofan engine, which is commonly used in commercial aircraft, the bypass ratio is the ratio of the mass flow rate of the bypass air that bypasses the engine core, to the mass flow rate of the core airflow, air that passes through the combustion chamber and the turbine stages. Higher bypass ratios indicate that a larger portion of the airflow bypasses the core, providing more thrust with less fuel consumption. Turbofan engines with higher bypass ratios are generally more fuel efficient and quieter, making them suitable for subsonic commercial aircraft. 1. Engine pressure ratio. The engine pressure ratio, also known as the pressure ratio or overall pressure ratio, is the ratio of the total pressure at the exit of the compressor to the total pressure at the inlet of the compressor. It represents the level of compression achieved by the engine's compressor. Higher engine pressure ratios indicate higher levels of compression, which result in higher combustion chamber pressures and temperatures. This leads to improved engine efficiency and higher thrust output. Engine pressure ratio values vary depending on the type and design of the gas turbine engine. Modern high-performance commercial turbofan engines can have pressure ratios ranging from around 30:1 to 50:1. High-pressure ratio engines are typically more efficient but require more advanced and complex compressor designs. It's worth noting that both the bypass ratio and engine pressure ratio are design parameters that depend on the specific requirements and intended application of the gas turbine engine. Different engines are designed with different combinations of bypass ratios and engine pressure ratios to optimize performance for specific operating conditions, such as subsonic cruise, supersonic flight, or short takeoff and landing.